Hi, welcome back to the channel. If, like me, at some point you've started out with one of the Baofeng or TidRadio type radios, you'll have probably thought to yourself at some point, right, how do I use this as a home-based radio with an antenna on the outside? And I'm kind of making this up as I go along, but hopefully you should be able to follow along with this, and we're going to make an outside antenna for your 2 meter, 70 centimeter radio. And as always, before we get started, I'll do a little bit of theory. Very simple theory, just to give you an idea. If you want to watch videos about advanced antenna theory and things like that, I suggest having a look at G5 Tango Mike, G5 TM or DX Commander, where they know a lot more about this sort of stuff than I do. I'm just going to give you some very, very basics. To build this actual antenna, we're going to need, I just got like this £1 chopping board. I got that from like a pound shop, a thrift shop. Couple of coat hangers. We're going to, all this will be in the description, links to everything. But this is some Coax antenna wire, 50 ohm Coax antenna wire. Again, I'll cover that in the theory bit. And it's already got an SMA connector on one end of it. Okay, so you can see it's actually got the SMA connector on the end of it there, and that end will just go straight onto the radio. And then we're more interested in chopping this end off and getting rid of that, and we'll do something else. I haven't decided which way around we do it yet. I may use a converter or something. We'll sort it out afterwards. Couple of coat hangers, some connecting terminals like this. Now these ones I'm going to solder them on, but it's perfectly acceptable, bear with me a second, to use something like, these type of crimp connectors. You can use these as well. So yeah, whatever you've got, whatever you need to use, it's entirely up to you. And what else? Oh yeah, and just a couple of nuts and bolts as well. Okay, let's do the theory bit, get that out of the way, just so you can kind of follow along and see why I'm doing what I'm doing. Again, I'm kind of making it up as I go along, but we'll see how we go. Right. Workshop paper, very dirty, never mind. Okay, let's get this. Right. If we draw a radio wave, looks something like this. Okay. Now, the distance between here and here, or here and here, can be measured, and we call this the wavelength. Now, for a 2 meter, 70 centimeter radio like this, the distance between here and here will be 2 meters. And when we're transmitting on 70 centimeters, this looks closer together, and the distance between here and here is 70 centimeters. Basically, any antenna that we ever make has got two sides to it. Your wire, not that, your wire has got two pieces of individual wire in there, the shield and the actual core as well. So if we draw the wire here, we've got the shield coming out on one side and the actual core coming out on the other side. And the basic principle of any antenna is, if you're building an antenna for 2 meters, then you'll have, this is a half wave dipole. Okay, it's half a wave because if this is 2 meters, the entire length of the antenna is going to be 1 meter because it's a half wave. And we're going to have one element going out in this direction, and we're going to have one element going out in this direction, and the total length is going to be about 1 meter. And that's how it works. Now, these are FM radios. FM radios, we tend to have the antenna going up and down like this. Okay, we call this the polarization. This is vertical polarization. People will be transmitting vertically polarized out of their radios. You want to be receiving and transmitting vertically polarized as well. When you get into some of the higher bands, we go this way and we have it horizontally polarized because it doesn't matter as much. You can have verticals and you can have horizontal aerials for HF radio stuff, but for VHF and UHF, 70 centimeters and 2 meters, it tends all to be vertically polarized. Now, as you can see, we've only drawn one element here. Because this is a dual band antenna, we're actually going to have a second element which is slightly shorter, and the total length from here to here is going to be half a wave of 70 centimeters, which is going to be from here to here 35 centimeters. That's all very rough and ready. The way we're going to do this is, when we make a dipole, a vertical dipole, we're going to have one part of the antenna here, we're going to have one part of the antenna here, and we're going to have our coax feeder coming away from the antenna at 90 degrees. So we have the antenna elements going up and down, and then 90 degrees going back, we have the actual coax. If you leave this dangling down here, it's going to interfere with this, it's going to cause problems, so we're going to have it that way. And what we need to do is figure out some way of making this and mounting it all together. What I'm going to do is I'm going to use the chopping board to essentially create something for this to sit on. Okay, right. It's all getting very rough and ready. I do apologise about this. We'll get onto the actual making bit in a second, but we're going to create a piece of chopping board that looks something like this. We're going to drill a hole here for the top element. We're going to drill a hole here for the bottom element, and we're going to have this bit coming back to give us something to put our coax onto. And then how we mount this to the house, or either on a pole or something like that, it's entirely up to you how you do it. What I'm actually going to do is I'm going to leave this part long enough so that it will fit into a piece of tubing, and then I can just shove that out of the window just for testing purposes. Right, the distance between this hole and this hole is going to be 44 millimeters. This needs to come back at least 30 centimeters. It's going to be a lot more than that because I'm going to have it on a long pole sticking out of the window. The antenna elements, the coat hangers, so that's one element, and it's going to be two of these, so times two. The shorter element is going to be 15.9 centimeters, and the longer element is going to be 47.3. So, and this is measured, this is actually going to be a curve here, and that's measured from the bottom of the curve to the tip of the antenna. All right, I'll make it, and then it's probably going to be easier to see it visually, and I'll give you all those measurements again. Okay, back in a moment. Right, okay, back again after the terrible explanation that I gave you, but let's show you what I've done, and then hopefully you can follow along. So if you remember, we were talking about that we needed the two elements, and we also needed something to mount it on. So this is the thing that I've done. I've chopped the chopping board down here. These two holes are 44 millimeters apart, okay? And this, normally, if you're just going to use this as the mounting part, you could leave it full thickness and put a U-bolt at the end of it. What I'm doing is I've got some of this tubing, and this is going to push into there like so with a securing bolt through it, and then that will go out of the window, and that will be my elements. The elements themselves have been cut down to the appropriate size. So as you can see, I straightened out that coat hanger. The longest part, now it's from the very edge, so if you start here and to the tip on this side, that is 47.3 centimeters, and it's the same for both of them. They're identical. And the shorter element, again measuring from here, from the flat edge to here, is 15.9 centimeters. So the long one 47.3, the short one is 15.9, and you make that identical. Now I bent these around a 9mm drill bit, and then I've just taken off some of that plastic coating because we want that to be conductive. We don't want any of that plastic coating on there. And what we're going to do is we're actually going to just put it all together now. So what I'll need to do is take my coax, which you can see here, I've just separated the shield and the center part out, and we're going to put one of these ring terminals on each, and then they will connect to here through the bolts, and the elements will also connect through the bolts going this way like this. I'll put it all together, and then I'll show you it all working. Okay, so there you have it. We have our antenna, which, remember, this is going to be up and down, not side to side like you see it here. I just can't show you up and down at the moment given the angle of everything. So what I've done is I've attached ring terminals to the back of these, and on the other side we have our elements held in place with washers. So that's it really. All I need to do now is I'm going to test this upstairs when it's out of the window and just where it should be, and just see how tuned in this antenna is. We can adjust it by moving the elements in and out slightly. So to do that, I'll need to take it upstairs. Once it's fine and tuned in and everything else, what we can actually do is we can put some liquid tape over the wires and over the connectors and things like that, just to make sure that it stays nice and waterproof. So the next stage really is to feed this into the pole, and once we've fed it, it's very difficult to limited space here, feed it into the pole, and then we'll put that out the window and just see how good it actually performs on our little Baofeng or TidRadio radios. So let's do that next. There we go, that's what it looks like from outside. So it's just literally sticking out of the side of the house, and it's pointing up and down. Let's see what happens. Okay, so from the outside shot you can see it's just a pole sticking out the window there with the antenna that I've built on the end of it. I have tested the SWR of this antenna. SWR stands for standing wave ratio. Standing wave ratio basically is the ratio of energy that's getting sent out into the atmosphere compared to the amount of energy that's getting reflected back. If it's a badly tuned antenna, you'll get more energy reflected back, and if you get too much energy reflected back, it will damage your radio. So this is the Baofeng UV5RH that I've got it connected to. The SWR was 1.4 to 1 on 2 meters and 1.2 to 1 on 70 centimeters in the sections of the band that I want to particularly transmit on. So yeah, it's a good build. I didn't have to adjust it at all. What we're going to do now is I've actually got the speaker mic, where is it? There it is, connected just to make it easier, and we're going to try contacting the repeater, which is the GB3HD repeater in Huddersfield, which is about 7 miles away. Can't usually get onto that from inside the house, but with an external antenna hopefully we will do just that. But let's give it a try and see what happens. Mike 7 Echo Uniform Papa, checking repeater access GB3HD and standing by for any call. Well, that's pretty good. We've activated the repeater, which is a good sign. Just waiting to see if anybody's actually on there who can respond to us. So let's keep on trying. Mike 7 Echo Uniform Papa, testing new antenna and standing by for anybody who may be able to answer the call on GB3HD. Mike 7 Echo Uniform Papa. Slight change of tact. I'm going to try calling CQ on the 2 meter calling channel and see if we get anything. So let's give that a go. Mike 7 Echo Uniform Papa, calling CQ on 2 meters. CQ, Mike 7 Echo Uniform Papa.
Golf 0, Tango Victor Bravo, calling you.
Golf 0, Tango Victor Bravo. Paul, I believe. Good afternoon, how are you doing? It's Matt here, Mike Alpha Tango Tango.
Fine, Matt, yeah, nice strong signal. Do you want to get out to 450?
Roger, on to 450. So he's asked me to go to a different channel now, so that's what we're going to do. Mike 7 Echo Uniform Papa, checking frequency in use. Is frequency in use? Standing by. Nothing heard. Golf 0, Tango Victor Bravo. Are you there?
Yeah, I am, yeah. 0 TVV, yeah. I am here, yeah. And sun's come out here. Nice now. It's terribly gloomy this morning, but it's brightened up this afternoon. Yeah, I was just thinking 2 meters seems to be quiet this afternoon. It's come out quite nice now. It's sun shining. I might wander off out later on. Anyway, yeah, I wonder whereabouts you are, Matt. I'm up at Hexham, so M70UP G0CV. It's not VHF really, but if you want to try 77s, I'll have a go, Matt. M70UP G0CVV.
G0 TVB. Yeah, okay, we'll give 77s a try, and if I don't hear anything, I'll come back to this frequency. What did you say you were? 433.5, over?
Yeah, that's the normal 77 calling. I don't think anybody else ever uses it. So yeah, 433.5. I'm listening to it now, over.
Okay, standing by, just changing frequencies. Ooh, so we can try 70 centimetres as well. This is working out well. 433,500. It's all very, very complicated. Right, okay. G0 TVB from M70UP.
Yeah, M70UP, G0 TVB. About 5 and 9, 5 and 7, 5 and 8 with me, Matt. I wonder how it sounds at your end.
Yeah, actually, it's picked up a little bit down this way for me, and I think this dipole's just a wee bit more resonant on 70 sems than it is on 2 meters, but it's working on both, over.
Well, it sounds okay, so if you're YouTubing, that's fine, it might be on the telly. This is the FT817 with a FT817. I was holding here on that as well, actually, so it puts out about 25 watts into the vertical. I've got a 62 and 70 vertical up here.
Wow, well, that was pretty amazing, to be honest with you. Good signal reports on both 2 meters and 70 centimeters with Paul, who's about 4 miles away, pretty much up over the other side of that hill there, in a place called Heptonstall, and yeah, great contact with him. So yeah, what can I say? The basic dual band dipole made out of coat hangers on a Baofeng radio works absolutely great. Thanks so much for watching. Please consider subscribing and hitting that like button if you want to see more videos like this, and if you want to see me live streaming on the HF frequencies, you can also do that by subscribing and being part of the channel. Thanks very much for watching, and take care, everybody. Bye.